Hello, we are continuing with the PYQs from the NET exam. Previously, that is from 2024, this one. We are continuing with the part involving mathematical physics. Here we have a matrix in the first bit. We'll try a few of them, and then we'll move over to the other topics. But first of all, let's look at the problem in front of us. We have a matrix A, which is given by the numbers that you see over there. The arrangement 1, 2, minus 3, 0, 3, 2, and 0, 0, minus 2. And we have to determine the eigenvalues, or we have to opt out of the given options. The eigenvalues of the matrix that is formed out of 3a cube plus 5a square minus 6a plus 2y, where I is obviously the identity matrix. Now, if you can take the cube of a, the square of a, and then the a matrix itself, add them up and calculate all of that. That's one way of doing it. Let's see if there's a more efficient way of trying this. What we can do is we can take the eigenvalues like this. So as a solution, we'll first of all consider doing this. That is, we'll have 1 minus lambda. That is, we'll do this in the form a minus lambda times of I. That will be fairly easy to try, I guess. Let's see if that gives us the answer efficiently. Then we have 0, 0, and we have 0, 0, and we have the last one, that is minus 2 minus lambda. This is of the form a minus lambda times of I, and we set it to be equal to 0. So we are actually taking the determinant, not the matrix. Let me erase that bracket over there. So what we are taking is that we are setting the determinant of this to 0. Let's see. Now, taking the determinant, it seems fairly easy because these two zeros are going to help us, because they won't be there for the rest of the other two terms. So what we are eventually going to get is 1 minus lambda, 3 minus lambda, minus 2 minus lambda. All of that is going to be equal to 0, because when we are taking 2, you are leaving out that column and the row as well, and eventually the zeros are getting multiplied onto the other two numbers. And even in case of 3 minus 3, when you're taking that row and column gets cancelled out, and the rest of the terms that were to be multiplied, they multiply with those zeros and they also give 0. So eventually we are left with this. So what this gives us, this is fairly straightforward. This gives us lambda to be equal to 1, lambda to be equal to 3, and lambda to be equal to minus 2. And we just have to put these values of lambda in this equation that is provided, that is 3a cube. So let's try first 3a cube. Instead of a, we are putting the eigenvalues over there. So 1 cube plus 5, a squared is 1 squared, minus 6a is 1, and then we have 2 with the identity. Obviously the value is going to be 1. So this is 3 plus 5, 8, minus 6 is 2, 2 plus 2 is 4. So 4 means we are left with only these two options, that is A and D. So that's good with the option bit, because we have, uh, as we proceed, we can just leave out the other options. They are going to be out of the equation. And if the second one is obtained, then we have the answer. We need not go to the third one. Third one, I'll leave it to you for you to try and check. So if I place the second value, that is 3, so I take 3 times of 3 cube plus 5, 3 squared, minus 6 times of 3 plus 2, and that is equal to, well, 3 cube is 8, is 27, 27 times of 3 is 81, plus 5 times of 3 squared is 9, is 45, minus this is going to be 18, and the last one is 2. So this is 126, minus 18 is 108, plus 2 is 110. So that is my option number D. That is the correct answer. So 4, 1, 10, and the last one is going to be 10. You can check for yourself by putting the value. What value? Well, you'll be putting the value -2 over there, and you can check for yourselves that if it is coming out to be correct or not. So this is the first bit. Let's try another question from the same year, that is 2024, the last time in June, which was conducted in July, of course. So now that's the question for you. We have two, or rather three operators over here, where we have A, B, we have A, B, and C operators. Difference being that A and B are Hermitian while C is anti-Hermitian. Now we have the following options to check. The first bit shows that it has the option that the first option, that is that the commutation of AB followed by the commutation with C is going to be Hermitian, and AC, the commutation of AC with the commutation and the commutation with B is anti-Hermitian. So I didn't write Hermitian over there, so I write rather H. Then we have the second option, that AB, the commutation of AB taken to commute with C, whether it does or not, and the commutation of AC followed by commutation with B, both are anti-Hermitian. And the third option has both the options the same, being Hermitian. The second option was for anti-Hermitian, and the fourth option is just the reverse of the first option. Uh, I think that that does not mean that that is going to be the answer. That's definitely not the answer. Let's see for ourselves what we are getting, and let's check. So now hermicity, first of all, I'll start the solution over here, and then move over to the next page. Uh, as far as the Hermitian operators are concerned, what we know is if we take the adjoint of that operator, then we get back the same thing, which is going to be the case with A and B over here. While in case of C, the adjoint of C is going to be negative of it. So that's anti-Hermitian. Now, there is a case that I have discussed earlier in one of my videos in operators part 2 of the operators, in the fourth installment to the quantum mechanical series, uh, which I have mentioned over here. You can see the I at the top, which will lead you to that video. What it tells us is that if we have two operators which are Hermitian, then the commutation of two Hermitian operators is going to be anti-Hermitian. This will be anti-Hermitian. This is already done, so I'm not going to do it once again. You can check the video for yourself. I'll obviously do the other one, so you can take the idea. In case you do not wish to watch the video, you can continue with this video and you will get the idea very soon. I'm going to do what I haven't done over there, that I'll use AC, which where one of them is Hermitian and C will be anti-Hermitian, and I'll try to do the commutation of both of them. Then we'll see what leads, or where do we proceed in that case. And we're going to do that in the next page, obviously. So in the next page we have let's check. We are taking A, the commutation of A and C, and we are taking the conjugate of it, the dagger over there, and what this will give us is C dagger, A dagger minus A dagger, C dagger, because as you know the orders will interchange when we are taking. This would have been AC minus CA, but having the conjugate of it, the orders just get interchanged, because AC, when taken the dagger of AC, the adjoint of it will give us CA. This is already discussed previously. I'm just providing it to you one more time. Now, C is anti-Hermitian, so this is minus of C and A is Hermitian, so A remains positive. A remains positive once again, and C is negative, so negative of negative becomes positive, so this is AC. Now, this is nothing but AC minus CA, which would have been the commutation of A with C. So the adjoint of AC, the adjoint commutation of AC is going to give us the same thing. So that means the the if we are taking the commutation of a Hermitian with an anti-Hermitian, then we are going to end up with a Hermitian relation, Hermitian commutation. So this is Hermitian. But we have more conditions to look at. So first up, we'll start with the three commutation form that we have: A, B, C. So in the first option, we have A, B, the commutation of A, B followed by commutation with C. We'll see where this goes. Well, first up, we'll be taking the adjoint of it, the dagger. Then what we'll do is we'll open this up. This is going to be A, B, C minus C, A, B, and the adjoint of it. This will be equal to, well, this will be equal to, let's see, uh, we'll apply the adjoint directly now. So we have C dagger, A, B dagger, that is commutation of it. And then we have A, B adjoint, C adjoint. Now C is anti-Hermitian, so this is minus C. AB is anti-Hermitian as well, so this is minus of minus, so the minus cancels out. This is going to be just AB. Then we have this as a negative of AB, anti-Hermitian, and then negative of C, and the negative cancels out once again. So what we are left with is CAB minus ABC, which is actually the negative of this inner term. So this is actually minus of ABC minus CAB. Not using the word commutation that frequently, but it's understood. I'm writing it down. So this is negative. So this is anti-Hermitian. We are taking the adjoint and we are getting an anti-Hermitian. So what we have done is we have we either it's the fourth option or the second option. That's what I like about these options, because you get to eliminate them. So it's either the fourth, that is B, or that is D, or the option B. Let's see the condition for ACB. So if that is done, we are clear, will be clear. AC with B. We take the dagger of it, then what we are going to get is B dagger. I'm writing it directly now. AC dagger minus AC commutation, taking the dagger adjoint of it, and B dagger. This has been provided directly. Now B is Hermitian, so it remains as such. AC is Hermitian, that also remains as such. And then we have the next two will be the same as well, because this is also Hermitian. Now this is actually the negative. This is actually the negative of what would have been the case, that is uh, negative of A, C, B, anti-Hermitian. So both are anti-Hermitian. So the option here is the option B, that both are anti-Hermitian. Okay, so having achieved that answer, let's move over to the next bit. It's another mathematical part that we are going to consider. Okay, in the next bit, we have an integral transform which is given by f tilde of x of a function fx. So that's an integral transform. And that can be regarded as a result of applying an operator, f operator, that is, as you can see over there, to the function such that when we apply this operator f onto fx, what it does is it becomes f tilde of x, which is in fact equal to that integration, that is from negative infinity to infinity dy e to the power minus ixy f of y. If, as we know it as I being the identity operator, what will be f operated 4 times, that is f raised to the power 4 acting on the function, be equal to? Now f being an operator, it will be some multiples of the identity operator as we have it in the option, that is 2 pi raised to the power 4 times of the identity operator, or just 2 pi times of identity operator, or the identity operator itself in the option 3 C. And in the fourth option, that is D, we have 2 pi squared times of the identity operator. We have to check whether the fourth whether the fourth power of f, that is applying the operator 4 times, what does it lead to? And we'll check that in the next page for sure. So this is pretty straightforward if you have idea about the Fourier transform. We had discussed the Fourier transform earlier in the assignment works that I did for one of my friends. So we have the solution. So this is the Fourier transform as we know it is f of s is equal to 1 over of root over of 2 pi. But this is missing in that equation, of course, and this is filled up in the options of this solution. We'll see how it goes. E to the power I s x fx dx. Now let's go back, or I'll rather write it over here. In this case, what we have is, you can afford to go back for sure. Let's go back a bit. In this case, what we can see over there is that instead of there has been a change. Instead of x in the bracket of the function f tilde x that we see over there, in Fourier transform it is s. So s is for x over there, and if you observe closely, you have y for x over here. In Fourier transform we have x. If we replace that by y, it's all the same thing, except for one major thing that we are missing out. In the power over there is a negative sign over here. That is a negative sign over there, down there, and the power of e has simply isx over here. So I'm rewriting this, of course. So in this case we have f operating on f, and what is it doing to it is that it is noted as f tilde of x, and what we have over here is from minus infinity to plus infinity. I am writing it in this form, I raised to power minus x, I'm keeping it in bracket. So x is for the s over here. This is x, this is s. So, but but of course we have minus x over here. So let's see, minus x times of y is again for x. Okay, so there's the x over there, but here there is y, and there's s over there, and here there is x, but instead of x, the conversion, the operator over here, that is doing some kind of mischief. It is converting it to the negative of it. So we'll see, we'll take care of that. So this is f of y dy. Now this would have been a Fourier transform completely if we would have had 1 over root 2. So let's just put that 1 over root 2 pi over there. Became a bit tiny. I'm writing it down with a bigger font, of course. 1 over 2 pi. I cannot just write it down like that. What I have to do is I have to multiply 1 over 2 pi, multiply a 2 pi. So there's an equal to over there. I'm erasing stuffs over here so that it'll be clearly visible to us. So this is f tilde x, and that is equal to some root over of 2 pi. I bring it over here and I divide the same factor over there. Now the bracketed term over here, the root over of 2 pi can stay as such. The bracketed term over here is nothing but f of minus x, isn't it? This is the Fourier transform of the negative of x. Mark very closely that if the minus x is replaced by the s and the y is replaced by the x, it goes back to this transformation equation that we have. So this is Fourier transform of minus x over there. And by what factor has it been multiplied? Well, this has been multiplied by root over of 2 pi. Now if I were to operate this the second time, that is f operated the second time, this time it is operating on f tilde of x, so that is going to give me minus infinity to plus infinity of e raised to the power I, and then we'll have a minus x, which was actually the which is actually the previous function that I'm writing down, this one, and minus I x times of y, f of y dy, and that is multiplied to root over of 2 pi. And again, if we were to convert it to completely a Fourier transform, then what we will be doing is that we'll be multiplying root over of 2 pi once again, just to get 1 over 2 pi. We multiply a root over of 2 pi and a 1 over 2 pi under root to this equation, and we get back that Fourier transform once again. So this root over of 2 pi was already there. We multiplied this to get a Fourier transform over here. So we have 2 root over of 2 pi's, so root over of 2 pi squared for the function acting the second time. Now this is nothing but f squared on f of x. So 2 times this is squared, and this is f of minus x once again. So 4 times would lead to root over of 2 pi raised to the power 4, and we'll be getting the same function over here. So that means root over of 2 pi raised to the power 4 is nothing but 2 pi raised twice, and whatever is there, because this is an operator which is acting, so this has to be provided with an operator on the right hand side as well. So this is going to be our answer, that is 2 pi squared times of I operator, that is the identity operator, which was probably the fourth option. So that's the answer for this bit. You can solve it this in this easier way, or you can go in a more tedious way as you like it, but this seems much easier to me because it's pretty straightforward that if it is getting squared, then you can take the cube and you can take the fourth power, you'll reach the same eventual answer. So there's no point doing that. Rather, you can consider you can make the comparisons and answer it in a more efficient manner. So that's more or less from this video. We'll be trying a few more problems from the other questions that are there from the previous years. This was from the 2024 June net exam physical science, which was held in July, of course. And we'll be doing a few more from that exam as well as from the previous exams. I have targeted at least for the last 5 years. I have a set of 6 or 7 questions to try. We'll try most of those questions, and hopefully they will help us in preparing for the upcoming physical science examination, which is to be held on 3rd or 2nd of March, I guess. uh, that is a Sunday. um, so let's see what we can do. Till then, thank you for watching.